Till now we have learned the basic of the acidic strength. To decide the basic strength, basic questions we have learned. Now we will learn some completed questions. As this is thing I have already explained. This is sp, this is sp2 iodized, this is sp3 iodized. So this will be more acidic than this, then this. Now this is a phenol, this is a phenol, this is a phenoxide ion. When we will make this conjugated base, then this will become a phenoxide ion. This is a phenol. This is unionized, this is a ionized. This is ionized form, this is ionized form. This is phenol, this is called phenoxide ion. This phenol, this phenoxide ion is more stable than this. So this is a more acidic. As this is after leaving this plus this minus charge. This minus charge will be more dispersed. This is more localized. This will more regenerating structures. So it will be the more stable. But this phenol has a plus and minus charge. Plus minus charge. Plus minus charge. As this having a plus minus charge in so plus minus charge. So this is a plus minus charge in all the compound. This plus minus charge. This is unlike charges are in the compound. Unlike charges. So unlike charges are in little short distance, long distance, but they are unlike charges. Unlike charges are spread, so it is a less stable. So unlike charges are spread in this compound, so it will be less stable. But this compound phenoxide ion doesn't having any unlike charges. Only a negative charge which is dispersed in all the in the whole compound, dispersing, changing positions. Now this is in position, this is second position, now in the third position, now fourth positions. So this minus charge is dispersed in the four positions. Now it will share by this four positions. So this will be the more stable. This phenoxide ion will be more stable than this. This phenol having negative charge, positive charge spread. That's why this will be the more less stable. Now I will explain a little bit with example. This is a phenol, this is a phenol. This is providing minus I effect. This is provided doesn't have minus I effect. This is a cyclohexanol, and this compound providing plus I effect. This compound providing plus M effect. All these things are same, but the group we have to consider. But this isn't having any minus I effect, plus M effect, any effect. This compound isn't having any effect, but this compound having effect, this compound isn't having any effect. So we have to compare the acidic strength. I've already explained minus I effect and minus M effect increase the acidic strength. This will withdraw the electrons. It will stabilize the negative charge by withdrawing the electrons. This will withdraw from the sigma bond. This will withdraw from minus I effect. Will withdraw from the pi bonds. Through the pi conjugation, it will withdraw the electrons. So similar things, this will all act as a withdrawing electrons. It will stabilize the negative charge. So it will it will do a compound more acidic. It will make a compound more acidic. So any group will be reacting, it will make the compound more acidic. Now we have to compare the acidic strength. So first of all, we check which compound has minus I effect or minus M effect. But this compound has a hyperconjugation, not minus I effect. This is a hyperconjugation. Hyperconjugation will push the electrons towards the compound. It will push the electrons, but minus I effect will try to withdraw electron to stabilize the negative charge. It will destabilize the negative charge because it is pushing the electrons. So this only this in this 5 compound, this is only having minus I effect. So it will be the more acidic than this all this compound. That's why first come in position. Now this second compound and third compound. Now this will come in the last position. Why? This and this we have to compare this two compound, but this hydrogen has a conjugation. This if it will become a conjugated base, this become O minus. O minus has a conjugation of this benzene ring, but this if it will become this O minus, it doesn't having any conjugation. That's why this will be the more acidic than this. It will come in the last positions. This is providing hyperconjugation plus this is providing plus M effect, but by providing this plus M effect, if it will become a conjugated base, this will O minus, it will also stabilize by the conjugation. But this compound doesn't having any conjugations, so it will come in the last positions, because all this compound have a conjugation. O minus, all the compound have a conjugation, but this compound doesn't having any conjugations, doesn't having any group. It will be least stable. O minus will be the least stable. That's why this will be the less acidic. That's why this third compound will come in the last positions. Now have to compare this three compound. Now this three compound, this compound have hyperconjugation, this compound having plus M effect, so it will be the less acidic then our second compound. So second compound will come in the second position. The first and second positions. Now in this now we have cleared that second will be in the second positions, first will be the first positions. Now first will be the higher acidic strength than the second. Now it will come in the last. Third will be come in the last. Now we have to three compounds engaged. Now have to compare between these two compounds. This is a hyperconjugation, this is a mesomeric effect. The mesomeric effect has a higher priority than the hyperconjugation. That's why this group will provide more plus M effect than this will provide a more and more this compound. This is a mesomeric effect. It will provide plus M effect. It is providing plus hyperconjugation means approximately plus effect. Similarly you can start this is a plus M effect. This is a plus means this will also push the electrons, this will also push the electron, but M effect higher priority than the hyperconjugation, so it will push more and more electron, so it will stabilize the conjugated base. If we will make a conjugated base, this will become a O minus. OH will be removing, OH minus will form, this will remove, minus will form. This will also push the electron, this will push the electron, this will more and more push the electron than the hyperconjugation. So the acidic, it will destabilize the minus charge, it will also destabilize, but less destabilized than this compound, so it will be less acidic than this. That's why fourth will come in the, and then fifth come, then the third comes. So first, second, fourth, fifth and third. So in this order, in this way we can decide the acidic strength. Now I will solve more and more examples. This is plus CS, this is CS3 as a two group effect, plus I effect and hyperconjugation. So hyperconjugation has higher priority than the plus I effect. Yeah, high effect, yeah, you can simply I effect. Hyperconjugation has a priority than the I effect. But this compound, all this compound having plus effect, yeah, hyperconjugations. But at the meta positions only I effect is acting, not a hyperconjugation. Hyperconjugation is not acting in the, this is ortho position, this is meta position, this is a para position. At the meta positions only plus I effect is acting, not a hyperconjugation. But this all these three compounds I effect plus I effect are acting. So I effect plus I effect are the distance dependent. So as the distance increases, plus I effect decreases. That's why this provide more and more plus I effect than this compound, than this compound. But hyperconjugation has higher priority than the I effect. So have to decide the acidic strength. Then have to make the conjugated base. It will become O minus. This will become a O minus. This will become a O minus. This will become a O minus. Now have to check the minus charge in which compound is more stable. As the stability of minus charge increases, acidic strength increases. But all this compound providing plus I effect, yeah, hyperconjugation. So all these three compound will be less acidic than this compound. This compound has only conjugations. It doesn't having plus I effect, yeah, hyperconjugation. So this will be more stable than all these three compounds. That's why now our first group will be this. Now which will be the second group? So this is providing hyperconjugations and plus I effect. This is providing hyperconjugation. This is providing only plus I effect. This is providing hyperconjugation and I effect. As the hyperconjugation is higher priority than the I effect, it will push more and more electrons. That's why you have to check the I effect. But these three compounds having only plus I effect, not having hyperconjugation. I've already explained meta positions only I effect are acting. Meta positions, not a hyperconjugations are acting. That's why this will be our more acidic than these other two compounds. So third positions will be come in our series. Now to check between these two compounds, but these two compounds both having hyperconjugation and plus I effect. So the hyperconjugations are equal. We have to check the I effect. These two compounds are distance dependent. I plus I effect are the distance dependent, so it is in the more distance, so this will be the less more acidic than this compound. This will pushing less and less electrons, so it will stabilize the minus charge, and this will push more and more electron, destabilize the minus charge. Both this compound pushing electron, but this is pushing less than this compound, so it will be the more acidic than this compound. Now our second group will become, now at the last fourth group will become, now this is a first, third, second, fourth, first, third, second, fourth. In this way we can decide the acidic strength. Now the next group will become like this group. All this compound having minus I effect, yeah, minus M effect, and it will also provide minus M effect, but minus I effect are the distance dependent, and minus M effect only work at the ortho positions. This is meta positions, para positions. Minus M effect only work at the ortho positions, yeah, para positions, not at a meta positions. It will not work. So at the meta positions only minus I effect is working, but these positions minus I effect and minus M effect is working. This position also minus I effect and minus M effect is working, but this group only minus I effect are working. So these compounds, all these three compounds having minus M effect and minus I effect, but this compound isn't having minus M effect and minus I effect, so it will come in the last. So first group will come in the last. So all these group are stabilizing the negative charge by pulling the electrons towards its by minus M effect or minus I effect. So that's why this doesn't having minus M effect and minus I effect, so it will come in the last positions. Now I will be in the last positions, it will come in the last positions. Now to check between these two compounds, but this compound having minus I effect only, but these two compounds having minus I effect and minus M effect also. So minus M effect are the equal, minus M effect are the work in the pi bonds, work in the conjugations. So have to check the minus I effect. Minus I effect are distance dependent. Mesomeric effect are the not distance dependent. It will only require a compounds to be conjugated. That's why minus M effect are the equal. Minus I effect have to check because this is a distance dependent. Now it is a more close to the OH group. Now this is a less close to the OH group. So that's why this will be our this will provide that's why we have to think. Now we are thinking that this fourth group will be higher priority than the second group. We are thinking that this fourth group will be higher priority than this group, as this group is a minus I effect and this is having minus I effect. This is in a more distance than this, so this group should be more acidic than this, but in this structure actually something is changed. This group is providing hydrogen bonding. This is providing hydrogen bonding with this H. Now here hydrogen bonding is shown. Now this is a hydrogen bonding. This group is providing this, making a hydrogen bonding. So after making this hydrogen bonding, it will trap the hydrogens. So it will not allow to leave the hydrogens to act as a acid. It will not allow to leave the hydrogens to make a acid. So in this way, this will make a less acidic. And the 2 minus I effect is providing more close. This is fine, but it will also work as a intermolecular hydrogen bonding. So intermolecular hydrogen bonding will tap the hydrogens. It will not allow to leave the hydrogens to act as an acid of this group. That's why it will now this condition will change, and now second will be higher acidic than the fourth. Then the fourth second will be higher acidic than the fourth. Now second will be higher acidic. The second will be our higher acidic than the fourth. Now it is clear. Now this point is clear. Second is higher acidic than the fourth. Now one is clear that first will come in the last positions. Now to check this group. This group is minus I effect only. This group has a minus I effect. So that's why this will come in the last of these two compound. Two other compound, this will come in the last. This is providing minus I effect only. This is providing minus M effect. This is providing minus M effect, but this is providing only I effect. Minus I effect, why? Because mesomeric effect is not acting in the meta position, so it will come in the last of these two compound. So it will third will come in the last. Third will come in the last. Now we have to check. This first will come. This three group are arranged. Now this first group always come in the last positions. Now in this way, second, fourth, third, first. Second, fourth, third, first. In this way, we can decide the acidic strength. If this group doesn't having hydrogens bonding between these two groups, in such case, fourth will be higher acidic than the second. But as the hydrogen bonding will be forming, now the order will be changed. Second will be more acidic than the fourth. Now this is a carboxylic acid. This is a carboxylic acid. After making this a conjugated base, now this compound is formed. This conjugated base is more stabilized, as this is negative charge is shared by these two compound by making a conjugated structure. By making a resonance, this minus charge will go to these positions. After negative charge, this will become plus. Plus minus will form a bond. This is a negative charge. Here negative charge will come, This is two structures. This minus charge is shared by these two oxygen atoms. So there is a dispersion of negative charge, there is a decoalization of negative charge. It is not only localized to one oxygen atoms. Minus charge is not localized to only one oxygen atom. It is decoalized by these two oxygen atoms. So it will stabilize this negative charge by the dispersion. In this way the stability increases. So this carboxylate ion, this is called carboxylate ion, is more stable due to resonance, and carboxylic acid are acidic in nature. That's why this carboxylic acid are acidic in nature, because this carboxylate ion is more acidic, more stabilized by resonance conjugating a structure. That's why carboxylic acid is more acidic. Now to check this acidic strength, I have already explained this thing. This fluorine, this minus I effect is working in the same position. This is a second, this is a carbon 1 methyl. There is the same position, but fluorine is more electronegative than the chlorine, then the bromine, then the iodine. This is a fluorine electronegative, then the fluorine, then the bromine, then the iodine. This is the more electronegative. This is a I effect. That's why this is a more acidic than this, then this. In this way, this thing I have already explained. But here is the 3 I effect is working. This is a 2, this is a 1. There is a no I effect. This is a 1, 2, 3. 3 minus I effect. This group having 2 minus I effect. This group having 1 minus I effect. This one having minus I effect. So it is more acidic than this, then this, then this. In this way you can explain the acidic strength. Now this group having plus I effect. This is a 1 plus I effect. This is this group is same. This is providing plus 2 methyl. This is providing 1 methyl. This is not providing getting methyl, because this group having you can say 2 plus I effect. This is 1. You can say actually this is actually 1. This is ethyl. This is ethyl provide more plus I effect than the methyl. This having doesn't have any group. So ethyl will provide more plus I effect. It will destabilize the carboxylate ion. As the carboxylate ion negative charge will form if you make a conjugated base. This conjugated base negative charge will require a minus M effect, minus I effect. This type of effect which will withdraw the electron to stabilize this negative charge. But this is providing plus I effect. But ethyl group, this methyl group, this doesn't having any group. So it will be the less acidic than this. So the increasing order of acidic strength will be in this order. Now similarly this groups, this is going to methyl group are present, 1 methyl group is present. So it will be the less acidic than this, than this. It will provide plus I effect, plus I effect. That's why they don't having any plus I effect. So it will be more acidic strength than this. Relative acidic strength. This is having R. This is a OH. This is a relative acidic strength. Carboxylic acid is more acidic than the water, then the alcohol, then the sp hybridized. This is NH3 and RH. In this order, the relative acidic strength need to be take care. If anyone confusing so many times, then need to be thinks about this. Carboxylic acid is more acidic than the alcohol. This is why acidic. This is a conjugated. There is in the conjugations. This compound doesn't having any conjugations, but O is more electronegativity. This group R group is providing plus effect, any group effect. It will push the electrons towards the compounds of the conjugated base. It will destabilize the negative charge. This is having sp hybridized, so it will be the less acidic than this. This is a NH3 and having lone pair. This is a RH. So in this way we can understand this is a lone pair, then the RH. This lone pair will stabilize the destabilize the negative charge. In this way we can think about this is a order need to be take care. In this is a experimental order need to be take care about the relative acidic strength. Now ortho effect benzoic acid. Ortho effect in benzoic acid is working only. Ortho effect means ortho whatever the compound in ortho position with respect to the benzoic acid. This is a benzoic acid. Whenever the carboxylic acid is there, this is called the benzoic acid. In benzoic aspect, the ortho effect is working. In ortho effect means ortho position. This is ortho, meta, para positions. At the ortho positions, if any group will be present, this will act as an ortho effect, and this compound will be more acidic. It is a common observation that generally ortho-substituted benzoic acid are highly acidic as compared to the isomer and benzoic acid itself. This is called the ortho effect in benzoic acid. However, exceptions are seen. Exceptions are there. So this ortho effect is more acidic. Now second is just simply more acidic. Now first having no any minus I effect, minus M effect, but these two compound having minus, this having minus I effect, this compound having minus I effect, and minus M effect. These two effects are working. This is a simply our ortho, by the ortho substitute. This will be more acidic, second will be more acidic, and first will be our last. First will be our last. Between these two compounds, have to compare. This compound having minus I effect only, and this compound having minus I effect and minus M effect. This compound having only minus I effect. This compound having minus M effect is one extra point. So this compound will be more acidic. Now fourth will come. Now third will come. Now in the last first will come. So second, fourth, third, first. Second, fourth, third, first. So in this way we can decide the acidic strength. Now this two compound. If we make a conjugated base, then this form will form. If we make this conjugated base, this compound will form. This, if you make conjugated base, this compound will form minus charge. If you make, there is no need to make the conjugated base. This is ortho is more stable negative charge. According to the ortho effect, this is a para, this is a meta. This is a para is minus I effect. This is having only minus M effect. So it will stabilize less the minus charge, and this is having minus I effect, minus M effect. It will stabilize more and more minus charge. So this is having one extra point minus M effect. This is having only minus I effect are common. But this is a more minus I effect. This is a more nearest. This is a meta position. This is a para position. Ortho meta para. This is your meta position. This is a para positions. So it will provide. If you compare only minus I effect, then this will be more acidic. But this is having minus M effect. It is extra point which is minus. This is mesomeric effect is more dominating than the I effect. That's why this will be more acidic than the meta position. So para will be more acidic than the meta, and the last benzoic acid will be there. Now to check chlorine, bromine, iodine. Now need to be take care that the fluorine, chlorine, bromine, hydrogen. This is a halogen. This group is a halogen group. This is called halogen group. At the if any halogen will be present, then this ortho effect of the benzoic acid. Benzoic acid, if any group will be present in the ortho effect, this will provide for ortho effect, and by the ortho effect, this will be more acidic. But if halogen group is present, this doesn't provide any ortho effect. Halogen effect are the independent of ortho effect. It will provide only minus I effect if halogen group is present. This is halogen group is present. Then this is shown in this is an by this there is a ortho, meta, and para. These three group are present. This is a benzoic acid are there. One is the ortho positions. One group is in a this is a meta positions, and one is the para positions. This minus I effect is more close to the COH. It will provide plus, it will provide minus I effect. This is a minus I effect. As the minus I effect are the distance dependent, so this will be more acidic than this in this. Similarly, here is chlorine, here is a bromine, here is a bromine, here is a bromine. The similar thing will happen. Bromine, fluorine, yeah, iodine. Halogen group are the independent of ortho effect. It will provide only minus I effect. Minus I effect will be higher priority than others. Whatever the property will be there, minus I effect will be greater in the halogen. In the halogen case, we only have to think about the minus I effect. So this will in this way we can compare the acidic strength. Here is the OCH3. This OH3 provide plus M effect. This is on plus M effect, but at the meta positions, this will doesn't having plus M effect. At the meta positions, it will be minus I effect. At the meta positions, it will work as a minus I group. Now in this case, at the meta position, if we make a groups, suppose if we make a compound COH, if you make a group like a Make one group. Suppose this group is there and the ortho positions OCH3 is there. Similarly, this group OCH3 at the meta positions. Now the similar group this is a para positions. This is ortho meta and para. And one group will be like this benzoic acid. Nothing any thing will be there. The of this compound is this in this way. This is shown. The meaning of this compound is this 4 group is there and OCH3 are attached. This OH3 will this in this positions will act as a plus M effect will work, and at this positions only minus I effect will work, but at the meta positions no mesomeric will be acting, only minus I effect will be working. In the order of the inductive effect and mesomeric effect I have explained. This is a OR. This is OR means this group is there. This will provide minus I effect. At this positions minus M effect. This is at this positions minus M effect is working. At this positions plus M effect is working, but this positions plus M effect is working. At the positions this is plus M, this is a plus M working, and this isn't having any plus M effect. I effect doesn't having any types of effect. But I've already told you that in the benzoic case, in the carboxylic acid is there in this benzene. This is called benzoic acid. This benzoic acid only ortho effect is working. If any other group will be there, there is no any ortho effect. But this is carboxylic acid when will be there, then there is a ortho effect will be working. Ortho effect means ortho substituted benzoic acid are highly acidic than the other compounds, any other compound. This is OCH3 is there. This is at the ortho position. This is a ortho positions. This is called ortho positions. OCH3 is present, but this group is a plus M effect. This group is providing plus M effect. We can generally, if you don't know the ortho effect, then you are thinking that this will be the less acidic. This is providing plus M effect. This should be less acidic, because this is providing plus M effect. If you make a conjugated base, then this minus will form and it will be push the electrons, it will destabilize this negative charge, so the stability increases this negative charge conjugated base, so it will be the less acidic. But according to the ortho effect, whatever the group will be there, this will be more acidic than the other compounds. So this is a plus M effect, minus I effect. We don't need to be take care. Only have to think this is ortho substitute means this will be the highly acidic. So this will be the higher acidic. As this is a highly acidic, now this is a fine. Now this is this group providing plus M effect. This is providing minus I effect. So minus I effect is stabilizing the conjugated base. So this will be the more acidic than this compound. So the meta, this is a meta position, this is a para positions, this is ortho position. So meta positions will be more acidic than this para positions. This meta position is more acidic than the para positions. As this is a OCH3 is there, this is providing ortho effect. This is a fine, but this is actually the group is plus M group, so it will little bit decrease the acidic extent. What this is a more acidic, this is a fine, but it will actually decrease the acidic extent, which will bring this acidic extent equal to this group. This ortho substituted benzoic acid and this meta substituted benzoic acid, these two groups will be having the same acidic strength, because this is a plus M effect. If any group will be providing minus I effect, then it is more acidic than the meta position. This is a fine, but this is a ortho substitute. This is okay. This is more acidic, but this is minus. This is acting as plus M group. This is plus M effect. This plus M effect is working. That's why it will little bit decrease this acidic strength. It will bring the acidic strength equal to this meta group. So that's why this meta group and ortho group will have same acidic strength. This need to be take care. This type of example is very important in the examinations point of view. If in examination this type of question is asked, if you don't know this type of concept, you will be going to surely make a wrong answer. You will surely make a wrong answer if you don't know about this concept. So this group is providing a plus M effect to the para positions, and this group isn't providing any plus M effect. So this group will be more acidic than this group. This group meta, this is a para positions, plus M effect is providing. So plus M effect will decrease the stability of carbonyl, the conjugated base. So it will be in the last positions. So or para compound will come in the last positions, and benzoic acid will come to the this position. So in this way we can decide the acidic strength. Now this is a hyperconjugation. Now hyperconjugation is providing this CH3 provide hyperconjugation, but at the meta positions only plus A effect is working. Here is a hyperconjugation and plus I effect is working. Here is a hyperconjugations and plus I effect is working. Doesn't having hyperconjugation and any effect, but this group has a hyperconjugations and plus I effect. This is having plus I effect only. So hyperconjugation is higher priority than the I effect. So it will push more and more electrons. It will push less electrons. It will push more and more electrons. But according to the ortho substitute benzoic acid, ortho substitute whatever the hyperconjugation plus M doesn't need to be take care. This will be more acidic. This is more acidic. You have to take care about this 3 group. This 3 group it doesn't having any plus I effect hyperconjugation. So it will be the come in the second position. Now ortho this is a benzoic acid in now second positions. Now between these 2 group you have to compare. This is providing hyperconjugation. This is an I effect. This is only high effect. So it will push more and more electrons. One hyperconjugation is an extra point. So it will push more electrons. It will stabilize the conjugated base. So this will be the more acidic. So meta will be more acidic than the para. In this way we can compare the acidic strength. We have to compare the maleic acid and the fumaric acid. Maleic acid is cis. This is a trans. What between this group which will be more acidic? Then we have to first of all the conjugated base. Conjugated base. This is conjugated base. Basis we are forming. This is a conjugated base we are forming by the negative charge. 1H will be leaving. This is more stabilized by this hydrogen bonding. This is doesn't having hydrogen bonding. So this will be the more stable. After if you lose a second H plus, if you lose second H plus, then this 2 minus will come in the same positions. So it will destabilize this compound. So it will negative charge will destabilize. But this is a 2 minus group in the opposite side. So it will stable then this compound. Fumaric acid is stable than this compound in the second acidic strength. Now I will written now K1 maleic acid is greater than the K1 fumaric acid. K1 first acidic strength is greater than this maleic acid. First acidic strength is greater than why this is making hydrogen bonding, but this is doesn't having hydrogen bonding. So this it will be more stable. In first acidic strength this will be more stable since the conjugated base is stabilized by intermolecular hydrogen bonding. But K2F means fumaric acid, maleic acid. Fumaric acid is more stable than the second since the maleic ion after donation of 2 group face each other and make system unstable in the fumarate. So in the second acidic strength the fumaric acid, this is a fumaric acid. Fumaric acid is more stable than this, but in the first acidic strength this will be more acidic than this. Why this? This is making hydrogen bonding. So that's why this is first acidic strength is maleic is more acidic than the fumaric acid, but in the second acidic strength maleic acid is less acidic. Why? There is a hindrance is there, but there is no hindrance. Two negative charge in a too much distance, but this negative charge is close to each other, so it will be less stable. So second acidic strength of fumaric acid is greater than the maleic acid. So in this way we can answer, because this question are asked in examinations. Now we will learn the relative acidic strength.